Okay, let's go over this one. This has had some difficulty here. So, highest point of the back wheel is 44 inches above the ground. The tire valve is 13. So the radius is 13. The radius is 13, and the max from the ground is 44. Is that right? Let's just jot that down here. 13 inches, and the max, is that 44? 44 inches. That's from the ground. Okay, so in order for the function's output to relate the tire valve position, the argument of sine or cosine must be the angle measured from 3 o'clock of the, so whatever angle you put into sine or cosine, the sine or cosine is going to give you a distance related to that thing, okay? So if you want the vertical position or vertical distance of the tire valve, you need to put the angle for the tire valve into sine. And that's what we're talking about, the argument, right? Okay, so the sine function that gives the height in inches of the tire valve above the floor. If both the pedal and valve start at 3 o'clock, 1 revolution of the pedal results in 1 revolution of the tire valve. Okay, so that means that the period, so the A is the angle measure of the pedal. So first of all, it's going to be height of the tire valve above the ground is going to be sine. But we need the amplitude, so let's just sketch this real quick. Midline is going to be what? If the max above the ground is 44 and the radius is 13, then what's the midline? 31? And the min would be 13 would be what, 18? Yeah. So the valve is going between 18 inches above the floor to 44 inches above the floor because the radius is 13. So 18 to 31 is 13, 31 to 44 is 13. So we got the amplitude then is going to be 13 sine. It's just going to be A, right? The angle measures are exactly the same for the pedal and for the tire valve, so there's nothing to mess with there. And then plus 31. So we need to move that midline up to 31 so that an additional radius gets us to the highest point of the tire, which is 44, lowest point on the tire, 18. Okay, so now we want a function that gives the height of the tire valve above the tire's horizontal diameter. What's going to change from this one then? If it's above the tire's horizontal diameter. So now we're measuring from the horizontal diameter, which means, right, so now the midline is going to be the horizontal diameter of the tire. So all we're going to need is just 13 sine of something, but no plus 31 anymore. So now, if the tire valve starts 3 pi over 4 clockwise from 3 o'clock. Clockwise, okay? So where is that? So clockwise would be around this way, so 3 pi over 4 would be here. So here's where the tire valve is starting, and then it's rotating counterclockwise from here. So is that cycle of the tire valve, is it ahead or behind the cycle of the pedal? Behind by 3 pi over 4. So if it's behind by 3 pi over 4, that clearly is what operation? Minus. So if it starts clockwise, but we're rotating counterclockwise, that means that the valve is always lagging behind by 3 pi over 4. So its angle would be the pedal angle minus 3 pi over 4. Was that the hard one?
Yeah. Yes, I didn't read that. It's clockwise. Right
Okay, so yeah, so we're rotating counterclockwise, but it's starting clockwise over here in the where I've drawn it. The last one's from the floor. Both the pedal and the so from the floor means again that we're going to add our 31. And so now we don't have a shift, but two. So this is a little tricky. 2 revolutions of the pedal results in 5 revolutions of the tire valve. 2 revolutions of the pedal is equivalent to 5 revolutions of the valve. So how are we going to think about this? So every time, so if we were to plug, so we need some expression here, B times A. And if we were to plug 2 in for A, this whole thing ought to be 5, right? So is that right? Yeah, that's right. Yeah. So when A is so you can just do it with radians too. That would mean that 2 radians of the pedal would be 5 radians of the valve, right? 2 revolutions of the pedal would also be saying that 2 radians of the pedal would be 5 radians of the valve. Okay. So when 2 is plugged in for A, then we need the tire valve angle to be 5. So you're plugging 2 into A. So what value of B does that? 5/2. So it's spinning 5 halves times as fast. So we want, as the tire valve spins, 2.5 times as fast as the pedal, according to this information. So that argument then would have to be 2.5 times the input angle A, or 5 halves A. Questions on this one? Yes, please. Can you what?
Request a problem. Like, I couldn't get 3C for the left.
3C. Okay, let's do it quick. There was high success on that one. Can we do it after class?
No, it's just C. Like, there's like a long thing, and I got all of them but the C portion.
1 rotation of the thorn means write an equation that represents the statement for the function f. So basically you're saying that the let's see it here. Oh, right. So this is what the pedal. This is the pedal angle measure, and this is the thorn angle measure, right? If this whole thing is about the thorn, then 2.8A is the thorn angle measure. So if we want to figure out the period, then we need that angle, we need that argument to equal 2 pi. But you've done this on many other problems, right? The same thing we did on lots of previous problems. It's like the way in which we find the period. We say the argument has to be 2 pi.
I tried. Okay, never mind. I know what I did.
You good? Okay. Yeah, but so this is similar to other stuff that we've done. But in order to find the period, the input that gives a full cycle, we'd say the argument equals 2 pi. That's the key.
And D is just solving for A.
And then you solving for the period. That's right. So solving for A gives you the period. Okay, so we got all these different aspects of these sine and cosine graphs, and we're going to put them all together in order to model real-world situations. So let's look at a strategy for that. So here's the general form. F of x equals A sine of b times x minus c plus m, or it could be cosine. All right, so we know that, so A is our amplitude. It's how much we're magnifying that fraction of the radius, right? Sine is going to give us a fraction of the radius. And so then A is how much we magnify that. That's the amplitude. B relates to the period. C relates to whether our graph is ahead or behind the standard conventional sine or cosine. And then M is the midline. So if you add a value to the graph, that's going to add that value to all the y coordinates of all the points, and or subtract it. Okay, so here's the order in which I suggest we work on it. Do the midline first. And so the midline is, for this graph here, can you see what it is? 2. Meaning every y coordinate is moved up 2 from the original midline of 0, right? The original midline is 0. We're taking that whole graph and we're shifting it up 2, so now the new midline is 2. Okay, amplitude is, so the amplitude's from the midline up to the max and the midline down to the min, so it's 3. Okay, so we want the value of b, which is going to come from the period, which we pull off the graph. So the first thing we got to ask is, does this graph relate to a pi scale? And that's the grid lines I have here. Or does it relate to an integer scale? These grid lines. So these grid lines are for integers, 1, 2, 3, 4, 5, 6. And then these grid lines are for pi scale. So which does the given graph relate to? Pi scale or integer scale? So I heard last few saying pi, and that's right, because if you notice this max right here, this max looks like it is exactly at 3 pi. But when I had that integer scale up there, none of those vertical lines matched up with any of these key places on the curve. But here it sure seems like 3 pi is right there at that max. So we're going to go with the pi scale here. And so how do we find b? So we think about the argument. Right? The argument is like b times the input. And if we want to find the period, we want that argument to be what? We've said this a million times. You want the argument, everything going into the sine or everything going to the cosine, to be 2 pi. The corresponding input then is the period, right? The input value that makes the argument 2 pi. So we're saying when and what, so we get the period now. So when we write the function, we're trying to get the value of this capital B. So we get the period from the graph, and then we solve this in order to solve for capital B, which is our coefficient within the equation. So what is the period from this graph? So where does it start over? So where does the cycle end and start over? 3 pi. So when the input, so thinking about input increasing here from 0, when it hits 3 pi, at that moment it hits 3 pi, the argument has to reach 2 pi. And we know we got a full cycle. And so then that value of b is 2/3. 2 pi divided by 3 pi, or 2/3. So now we're going to, all these graphs we're going to write both as sine or cosine. So we're going to start with the easier one. So what would be the easier, the route of least resistance here, to choose sine or cosine? At 0, cosine starts at our max, right? And then makes one full cycle back to the max. So we're going to start by doing cosine. And when it's cosine, we don't have a horizontal shift here. That's why we picked that to start with. It's easier. So we could write, let's call it f of x. And we're ready to go. It's going to be in this form, but cosine. So what is a? 3 Give me more room here. 3 cosine. B is our 2/3. What is C? C would be how much or ahead or behind our graph is of the standard cosine. 0, right? So it is a standard cosine. So C is 0. Plus M, 2. Okay, but now we want to write it also as a sine. Okay, now we want to write it also as a sine curve, because these can all be written both as cosine and sine. So we want to look here, and what are we looking for? So the first thing we want to do is sketch the conventional sine. All right, so at 0, where does the sine start? The min, the midline, or the max? Midline, right? Starts at the midline. And then in the first quarter period, it goes up to the max. Thinking about what? Vertical position on the circle. Okay, and then in the next quarter period, back to the midline, and then it goes to the min, we know, in the third quadrant. So this would be an unshifted sine. This would be unshifted sine. Our graph, looking at the closest, so now you're looking for the closest cycle that looks like that in our graph, in the blue one. And then you ask, does the closest cycle in our graph, the blue one, does it come ahead or behind this unshifted one, and by how much? Does it come, first of all, does it come ahead or behind? So did you learn what we talked about on Monday? Starting as theta moves from left to right, does ours start before or after? Before. So is it ahead or behind? It's ahead. It's coming before, right? So here's the cycle we're looking at. The closest cycle is right there. Sine. Starts at the midline, max, midline, min, midline. Do you see that it's coming ahead of the unshifted sine? It's coming ahead by how much? How much ahead is it? Nope, we're on a pi scale, right? These are on pi scale. Each one of these is, here's pi right here. Here's pi. Here's 2 pi. So each one of these horizontal vertical lines is 1, 2, 3, 4. So how much ahead is our graph? 3 pi over 4. Each one of these lines is pi over 4, and there's 3 of them. Each vertical line is pi over 4, and there's 3. So our graph, the one we were given, is starting ahead of, or in front of, or leading this unshifted sine by 3 pi over 4. And so now we're ready to write it. So we could also write f of x as 3 sine of 2/3. Make sure you put this part in parentheses. So plus or minus 3 pi over 4. It's ahead. Our angle is, since it's ahead, the angle for ours is greater. It's greater by 3 pi over 4. That's why it's ahead, right? It's ahead as it's going around. So we're going to do plus 3 pi over 4. Okay, so there's lots to keep track of, lots of reasoning we used. To get it right in web work, everything has to be right. Okay, so any questions? Both of these model the same blue graph. Okay, so here's the deal now. So suppose this was modeling, say, some vertical distance of something. All right? I don't know, maybe this is another water wheel, and this is actually doing what it should because the bottom of the wheel is going into the water, okay? So this is a water wheel. And this is tracking the height of a point on the water wheel, which is vertical distance. So notice that that can be written as a cosine. So what did we say? From the beginning, we said cosine was what? The horizontal distance of the point on the circle from the vertical diameter. And we said sine was the vertical distance of that point from the horizontal diameter. But now when we start modeling real-world situations, any curve, any sine or cosine curve can also be written as the other. So even though this would be modeling, say, the height of a point on the wheel from the water, from the surface of the water, it can be written as a cosine. Okay, so this could be, this curve right here, 3 cosine 2/3 x plus 2, could be modeling vertical height from the water of a point on the wheel. Does that make sense? Even though the origin of cosine is to model horizontal distance. So I always get this question. How can it, this said vertical distance, so it has to be sine. No, it doesn't have to be sine now that we're doing these real world situations. Anything that can be modeled with sine could also be modeled with cosine because of a horizontal shift, bringing a horizontal shift into it. And anything that's modeled with cosine in the real world could also be modeled with sine. So when we're modeling in the real world, we lose that rigidity to cosine is horizontal, sine is vertical. They both can be both now. They both can be both. Does that make sense? All right, you guys try another one. Okay, so here's your strategy. You're going to write this purple graph both as a sine and as a cosine. Work together. Lots of homework on this weekend, doing this kind of thing, so make sure you got this. Oh, first we got to decide, is it going to be the integer scale or pi scale? So right now I'm showing pi. Okay, midline. Midline is -1. Amplitude? 2. That's the easy stuff. Okay, period. No, the period. Period is 2, so we say b times 2 has to reach 2 pi. When the x value is 2, we want the argument to hit 2 pi. b is pi. Okay, easier as sine or cosine first? This is unshifted sine, right? It starts at the midline and goes up. Starts at the midline and goes up. That's unshifted sine, so we'll start with sine. F of x equals, we're ready to do it. A is, so 2 sine of b is pi, no horizontal shift, -1. Okay, so now we want to write it as a cosine. Start by sketching unshifted cosine. Unshifted cosine, min, midline, or max does it start? Max goes to the midline, then down to the min at the halfway point of the cycle, back to the midline, up to the min, or up to the max. So there's our unshifted cosine. You look for the closest cycle of cosine that looks just like that, the closest one. So the closest one that I see starts here and ends here. So that, what we have, is it ahead or behind the unshifted cosine? So thinking of x increasing from left to right, unshifted cosine cycle starts, and then later our our cycle of cosine starts? How much later? 1/2. 0.5. So we have a cosine graph that's starting a 1/2 unit later than unshifted cosine. So we can write it as 2 cosine pi x minus 1/2. It's coming later by 1/2. Did anyone see a different cycle of cosine? So you can do this. There's another way to do this. Instead of looking from here to here, you could look at this cycle, right? From here to here. This is valid too. It's just further away. And so this cycle of cosine, is it ahead or behind the unshifted? It'd be ahead. Ahead by how much? 1.5. So if you wanted, you could have done, in here, you could have also done x plus 1.5 by looking at that cycle, that earlier cycle, right? That earlier cycle is 1.5 ahead of the unshifted cosine that I sketched here. So you can do x minus 1/2 or x plus 1/2, and they're all three of those would give you the same purple graph there. Anybody have a question?
When I put in my calculator, it doesn't quite figure out exactly what the sine rate would be.
Show me your y equals. Which one are you doing? 2 sine x minus 1. Yeah, because you didn't put the right parentheses. Look at how I have it. Pi times quantity x minus 1/2. You've got, so this is a common mistake. You can't do this, right? And that's kind of what he did. You can't do pi x minus 1/2. That's different. That's not right. Red. Okay? You've got to do pi times the quantity x minus 1/2 for all our reasoning to be correct. Pi x and then minus 1/2 is something different. That's something different, so that's not going to work. Does it work now? Does it work? So make sure that you're doing b times, in parentheses, x minus c. One more, and then we'll do a real world one. There we go. Okay, one more. Go. All right, first we got to decide, pi scale or integer scale? Here's integer. Does it look like it's integer? I'm going to leave it on integer. It's integer, okay?
Yeah, it just needs to go left because C is a midpoint. Two. So yeah, shift like you shifted the entire around by 0.5. Zero. Or side. Start.
Okay, what did you get for the period? 6. Which means that when x reaches 6, the argument has to reach 2 pi. So b is going to be 2 pi over 6, or pi over 3. Okay, so is this most easily written as sine or cosine? They both need a shift, right? You should have concluded that if you're going to use sine, you need a shift. You can use cosine, you need a shift, because it doesn't start at the max, and it doesn't start at the midline and go up. If it starts at the midline and goes up, that's sine, unshifted sine. If it starts at the max and goes down, that's unshifted cosine. But we don't have either of those cases, so both require a shift. So what do we want to do first? Cosine first, okay. I see cosine a little bit easier here. So it's going to be cosine, it's going to be 1/2 or 0.5 cosine. And we said pi over 3 was b. Make sure you have parentheses here. X, and the midline is -2. So sketch a unshifted cosine, which is going to go from 0 to 6. It's going to start at the max, and at 3 it's going to be at the min. 1.5 the midline. So this is what I'm seeing here for unshifted cosine. Is it right? So that black thing is unshifted cosine. We look for the close, to make it easiest, look for the closest cycle that looks just like that. And ask, is the closest cycle that looks just like that on our curve, is it ahead or behind the unshifted cosine, and by how much? Ahead or behind? It's ahead. If x increases from left to right, it's starting first, right? If you think of x coming off the screen, and now which one's going to come first? Ours, the red one. So it's ahead. It's ahead of the unshifted cosine by how much? By 1. It's ahead by 1, so it's going to be x. The angle is, it's ahead, the angle is greater. If it's ahead, then the angle is greater by 1. Pi over 3, x plus 1. Make sure the x plus 1 is in parentheses. Questions on that? How many got it before I started? How many got it? Oh, a lot. Good. Okay. How about sine? Everything's the same except the shift. So we sketch. Oh, I should have. So we sketch I'll do it in blue, so hopefully it'll stand out. I'm going to do unshifted sine. Unshifted sine in blue. Where's the closest unshifted, or the closest sine cycle on the red graph? Here. The closest one is here, from here to here. Ahead or behind, and by how much? Ahead by 2.5. Ahead by 2.5. So our graph, the closest one is ahead by 2.5. You could have done behind by, you could have done this cycle. And this is behind by how much? 3.5. So for sine we could do x plus 2.5 or x minus 3.5. Both work. Okay, lots of homework like this. So you got to have this down. Any questions? Okay, let's do it. Let's take it a step further here. So now we got a real world situation. Last chance to ask about this one. So when you have a real world situation like this, what you want to do is first take the information and sketch the graph, right? So you're going to get this, take this information and sketch the graph, and then all you have to do is do what we've been doing the whole class period. Okay, so a yo-yo cycles between a low point of 4 inches above the ground to a high point of 32 inches above the ground. It takes 1.5 seconds to move between those low and high points, meaning from low to high or high to low. Okay, model the height, and we're assuming that is what we call sinusoidal, right? So it's like a sine or cosine, okay? Which probably is not the case for yo-yo, but it's something, okay? So we'll just assume that it follows sine or cosine pattern. So we're going to model the height of the yo-yo, not yo-yo, yo-yo, above the ground as a sine and cosine curve if the yo-yo is at the low point at t equals 0 seconds. So what we have to do first is, given all this information, can we sketch a graph like we've been starting with all class period? So I'm going to take this one off. So do I want pi scale or integer scale? What's going to be our x-axis quantity? Angle measure? No, time in seconds, right? Time in seconds. So do I want pi scale or integer scale? Because it's in these increments of 1.5 seconds, right? Increments of 1.5 seconds. Okay, and so I need, let's just do this as 10, 20. Instead, let's make this 10, 20, 30, 40. So that our y axis is going to be the height of the yo-yo above the ground in inches. Okay, so where do we start? We want to sketch this graph. If we can sketch the graph correctly, then we just apply what we did all class. We've got the graph. We can write the function. Okay, so how do we sketch this graph? What's one point that we know?
Where it starts.
Where it starts. T equals 0 seconds. What's the height? 4. And then what happens? What's next? At 1.5 seconds, it will be at 32, right? It's saying it takes 1.5 seconds between low and high and between high and low. So 1.5 seconds later, it will be at 32. And then 1.5 seconds after that, it will be at 4. And then at 4.5 seconds, back to the high again. So that's enough for a sketch. So it's going to look like this. And then so it's 0.75 seconds, it'll be at the midline. What is our midline? It's going to be halfway between the max and the min. 18 is our midline, so let's sketch that. I'm just going to put that in here. Oh. Okay, so there's a midline. So then it's going to go from, it's going to hit the midline there at 0.75 seconds and at 2.25. So make our sketch first. Make a good sketch. Okay, and so if we got the sketch right, then we just apply what we did. So to underscore the fact that this is a measuring vertical height, vertical distance above some horizontal place, the ground, let's write it as a cosine, just to underscore the point that cosine or sine can both model this vertical height application problem. Doesn't have to be sine because it's a vertical height, although that was the origin of sine. So we're going to use cosine to do this. So what's our amplitude? Fast? Amplitude is 14. That's from the midline up to the top. Cosine What's our period? Period is 3. So b times 3 is 2 pi. Therefore, b is 2 pi over 3. We'll do the shift later. And then the midline is up at 18. So we got 14 as the amplitude, midline shift of 18. The period is 3 seconds, so that makes a b value of 2 pi over 3. And so now we sketch the unshifted cosine, which is going to start at 32, right? There's unshifted cosine. And so if we look at this cycle right here, starting here to here, it is ahead or behind by how much? Behind by, it's coming later, right? So the unshifted cosine cycle starts, then later, coming behind, 1.5 seconds later, the cosine starts, or the R starts. So we could do x minus 1.5. So this graph models the height of the height above the ground of the yo-yo x seconds after it was at the lowest position. So x seconds after being at the lowest position, this will give you the height in inches.